Alright, so this is the QUA5 notes, Quadratic Inequalities. This set of notes should be relatively brief, but I am going to make two videos on it, one covering the front page of the notes and one covering something on the sample problems that I forgot to cover on these notes. Okay, so p squared plus 10 equals 7p. Now, we're solving each quadratic equation using any method. This means we can solve it using factoring, quadratic formula, or completing the square. Alright? So the first method that we should always try is factoring. So we're going to try p squared minus 7p plus 10 is equal to 0. Right? Because we subtracted 7p from both sides to get into this form. And let's try a cross puzzle and see if it works. So on the top we're going to have a times c, which is 10. 1 times 10. And on the bottom I'm going to put my middle coefficient, b, which is negative 7. And we're going to try to find two numbers that multiply together to give me my top, which is 10, and add together to give me negative 7. And I will tell you, this one does work. So, the two numbers on the side, if you want to pause and figure it out, that would be a good idea. Alright, they are negative 5 and negative 2. If you put them in the other order, you'll get the same answer. Now, you don't have to split the middle term. You don't have to split the middle term because our leading coefficient is 1. So because our leading coefficient here is 1, you can write this as 2 factors, where the other parts of the factor are just the two numbers on the side. Alright, so now, because we have two things multiplied and they equal 0, one of them has to be equal to 0. So we have our first case where p minus 5 is equal to 0, and our second case where p minus 2 is equal to 0. Now we're going to solve both for p. P equals 5 and p equals 2. Okay. Now for this one. This one isn't quite as clean, unfortunately. We'll try it though. X squared plus 4x minus 4 is equal to 0. We're going to try factoring it first. Alright? Now the cross puzzle method, let's see if it works. So a times c is negative 4 because it's 1 times negative 4. And then we have positive 4 on the bottom. Now unfortunately there aren't two numbers that multiply together to give me negative 4 that add together to give me positive 4. The numbers that multiply together to give me negative 4 are negative 4 times 1, which add together to give me negative 3. Negative 1 and positive 4, which add together to give positive 3. And then negative 2 and positive 2, which gives 0. So there is no way to factor this left side. So instead we're going to use either quadratic formula or completing the square. So, if you want to use completing the square, that's what I would use here because this bx term is even, which means it can be cut in half very easily. And we already have, and the leading coefficient is 1, and we already have a constant over here. So that's why I would use completing the square for this, but it is completely up to you. So it does not factor. And then we try this. We're going to try completing the square. So now when we cut this b term in half, we're going to cut it in half. We got 4. We're going to cut it in half and then square it. So if we cut 4 in half, we get 2. I'm going to do that to both sides. I'm going to add a 2 squared to both sides. Because remember, to complete the square, we need to cut the middle term, or cut the middle coefficient in half and then square it. And then add that to both sides. So, this is now a perfect square trinomial, so we're going to write it as x plus 2, all of it squared. And then this is equal to, well, 2 squared is 4, so 4 plus 4 is 8. And now we're going to take the square root of both sides, and don't forget the plus or minus, because we don't want to neglect both of the solutions. It's going to cancel these out. X plus 2 is equal to plus or minus the square root of 8. The square root of 8 is not a prime or a perfect square, so we're going to see if we can break it down. We got 4 and 2, 2 and 2. I am working very quickly here, so if you want to pause and work ahead, that would probably be a good idea. All right, so now we're going to look for pairs. We have a pair of 2's, so the only thing on the outside should be a 2. And then we have a 2 left underneath, so that's going to be a square root of 2 underneath. All right, so now we get x plus 2 is equal to plus or minus 2 square roots of 2. And when we subtract 2 from both sides, I'm running out of space here, we get x is equal to negative 2 plus or minus 2 square roots of 2. So our final answers are going to be x equals negative 2 plus 2 square roots of 2 and x equals negative 2 minus 2 square roots of 2. Okay, so now for inequalities, the process is actually very simple. The process is exactly the same. We're going to solve the inequalities exactly like they're an equation. It's exactly the same until the very end. Now, there is one caveat that, again, I forgot to mention on the front part, so I am going to make a separate video. Actually, no, I think I'm going to actually attach it to this video now that I'm thinking about it. So we've got greater than or equal to. We're going to use the or notation. So yeah, x is less than something, or x is greater than something else. And we have this or in the middle. So we're going to use the or notation. If you want an acronym, you can remember great or. So greater or greater than. It's a little cheesy acronym, or not acronym, mnemonic device. So if we have greater than or equal to, we're going to shade outward. Now note there is an exception to this, and again, this is the caveat that I mentioned, so we're going to cover that on the back. All right, if we have less than or equal to, though, as a general rule, we're going to use the compound notation, where x is between two values. This one's the lower one, this one's the upper one. All right, and we're going to shade inward. All right, so for this first one, I want you to notice that the only difference between this problem and the first one up top is that there's a less than sign. Now, I'm going to be working through this very quickly, so if you need to get any of this still, I need you to pause the video now. Okay, so our answers to this problem were p equals 2 and p equals 5, and I am putting them in ascending order here. All right, so now we're going to plot this real quick. We have 2 and we have 5. I'm using open circles here because this is a less than symbol. And we're going to shade inward. Why do we shade inward? Because it's a less than sign. We shade inward. And we also use the compound notation. So now, because we're using the compound notation, the lower solution goes here, the upper solution goes here. That's really important. If you try to put 5 and 2 here, it is wrong, completely wrong. So make sure that you have 2 first and then the 5. Okay. All right, now, for this next one, our solutions were x equals negative 2 minus 2 square roots of 2, which is the lower solution, and x equals negative 2 plus 2 square roots of 2. Because this is the same as the second problem on the top. It's the same as the second problem on the top, except it has a greater than or equal to. Okay? So, because it's greater than, we're going to be using or notation. So we're going to say that x is less than, well, first of all, before I do this, we need to figure out where they are on the number line. If you type these into Desmos, which I highly suggest that you do right now, you should get a decimal answer, and that will tell you where on the number line it should go. So for the first one, we get an x value that's about negative 4.828, I think. And for the second one, we get approximately 0.828, positive 0.828. So those points are going to be between -5 and -4, and between 0 and 1. And we're going to write this using the OR notation. Again, we're going to put the lower one first. So this is going to be -4.828, because again, this is shaded outward. This is shaded outward, remember. This is shaded outward because it's greater than. So because it's shaded outward, this first solution set before the OR has to represent this first shaded area. So because it's being shaded to lesser values, we need to put the less than here and then the lower bound. And then for the second one, we're shading to greater values, so we're going to put the upper bound and then a greater than symbol. I actually don't like it written with the decimals though, so the best way to write this, and the way that you're going to see it on a test, is like this. All right. So now we're going to flip to the back, and I'm going to show you the one caveat. All right. Here we go. So I'm going to skip, actually, yeah, I'll get you started on these problems. So this first one, if you want to use quadratic formula or factoring, you can write it like this. And you will still get the same answer if you solve this like an equation using factoring. It will work, trust me. Now for this one, we're going to do the same kind of thing. We're going to write this in a certain way. Now, keep in mind there's no bx term here, so we can actually write this as 0x plus 9, like that. But the caveat is right here. That is a problem. When the leading coefficient has a negative, this is a problem. So I need you to write at the top, all right? All right, if the leading coefficient is negative, your sign will get flipped. At some point. And by sign, I'm talking about these signs. So just keep that in mind. If the leading coefficient here is negative, then your sign is going to get flipped. Okay? So, what we really are going to be looking at when we solve this, and you can solve this just like normal. When we solve this, ultimately, even though it says less than here, because our leading coefficient is negative, we need to treat it as if it's a greater than. And so we're going to be using the OR notation, and we're going to be shading outward. Even though the leading coefficient, even though this says less than, the leading coefficient is negative, so we have to think of it as if it were greater than from the start. All right. We're going to do the same with this one because it has a leading coefficient of -2. But for this one is greater than, because our leading coefficient is +1. But yeah, so this is just a rule. If your leading coefficient is negative, we have to think of it as if the sign is going to be flipped at the end. The solving process is still going to be the same, but we have to think of it as if it's flipped at the end. And the reason why, I will say the reason why. The reason why is because if we were to divide everything here by -1, to get rid of that negative out front, we would be left with x squared plus 0x minus 9, and then this would flip the inequality sign because we're dividing by a negative number. Like that. And so, because we end up with something like this before we even start, if we do this, we have to treat it as if it's a greater than. That's the reason why. So that's just something to keep in mind that I forgot to mention on the front. All right. Finish the sample problems. Go Cavs.